You're set. John, you're live. John?
Yes.
You're live. Go ahead.
Okay, thank you. All right, well, hello, everybody. I'm in New Zealand where it's tomorrow afternoon. It's 1:15 in the afternoon. Thank God it's Friday. And I wish I could be there with you, but for various reasons I can't. So instead, I'm doing a remote presentation on modern authentication with VFP. Now, modern authentication's actually got an official definition, and much of what I'm going to cover today might not meet that definition, but hopefully it's still useful. So without further ado, this is my About Me screen. I am a qualified medical doctor. I've been using FoxPro since the FoxBase days, and I'm notoriously paranoid about security, and that leads me to be giving a presentation like the one I'm giving today. There's a few things I'd like to cover today. So first of all, there's two-factor authentication, which is basically in addition to the username and login that we're all familiar with. This is a second authentication mechanism. It's used widely by banks and other applications. And hopefully I'm going to show you today how easily you could integrate this into your Visual FoxPro work. And then there's some alternative login mechanisms in addition to the classical or default logins that we've all been writing in Visual FoxPro in some cases for decades. So there's auto login, which basically means you interrogate the Windows username, and as long as that Windows username has privileges in your application, they're logged in. There's AD authentication, which means you still provide the user with the login dialog, but instead of authenticating them against your user table, you authenticate them against the customer's Active Directory. There's LDAP authentication, very similar to Active Directory. And then last, there's fun with OAuth, or more accurately with OAuth 2, which is modern authentication. The goals of what we're doing today are we want to have pure Visual FoxPro solutions. We don't want to have external dependencies. We can't afford to use a scripting host or PowerShell because they're often disabled by customers. And even if they work today, there's no guarantee that your mechanism is abruptly disabled tomorrow when a new security protocol is introduced. We don't want any phoning home. This needs to be encapsulated in VFP code that is not leaking anything into the wider ecosphere. And we'd like it to be closely integrated into existing mechanisms so that there's not wholesale rewrites and we're not having to redo lots of stuff. So if we look at the classical authentication, which is what most of us have been using, we've got our own user tables and a login dialog of some sort is produced, and we authenticate the user against the user table. In the old days, we might store a password in the clear or an encrypted version of the password. More recently, I think most of us use to hash values. And a lot of us have got custom mechanisms like password templates requiring combinations of special characters and so forth. What I find is the more that you can do, the more they ask for. So I've been asked for a mechanism to prevent users reusing their last 6 passwords or anything similar to them. And of course, if you're using hash, then you've got no way of recording similarity because a 1-bit change in the password can change the hash enormously. So when that happens, it's great if you've got an inbuilt mechanism where you can say to them, well, look, you've moved past the capabilities of our classical authentication And now you can move to the rich functionality provided by Microsoft in its Active Directory and no longer rely on me. So we've talked about the various options that are available. You've got the auto login, the AD, LDAP, classical, and then plus or minus two-factor authentication. And here's just a little picture. So the model that I would recommend is you've got settings, and if the auto log setting is yes, it harvests the Windows username, and as long as that user's got application privileges, they've logged in. If that's not set and the Active Directory setting is set, then up comes the login dialog, and instead of validating against the user table, you perform the AD integration we're about to look at, and if that passes, they're logged in. If the Active Directory setting's not there, LDAP, same deal, you get the picture. If none of those settings are there, then it carries on as it always did. So technically you could implement this and it has no change for the customer unless they ask. And that's quite a nice model to have, as long as the stuff's not too difficult to implement. And hopefully I'm about to show you that it's not. There is one point. You need the usernames in your application to match the usernames in the user's and the customer's AD, because otherwise, obviously, this won't work. In my case, that's almost always the case, and so there hasn't been a problem. But if you've got usernames that differ from the AD, then you might have a problem. I'm sorry about that. All right. So I thought I'd start with two-factor authentication. It is late in the day. I had an absolute blast doing two-factor authentication the first time I did it, and hopefully for some of you, I can give you the same. So, also called two-step verification, and it's basically a second authentication when the user's logging in. And there's sort of 3 or possibly 4 basic mechanisms for 2FA. The oldest is the text message. That's frowned on in 2023 for a number of reasons, including that as devices get bigger and have more resolution, vendors are trying to increase their attractiveness to users, and so that the preview, the text preview that often appears on your screen when a text comes in, that often can include the text code. If you're texting a code, as the ability to display gets more and more, and that kind of ruins the point, in that if a hacker has got the user's login in their device, they don't need to log into the device if they can just read it off the screen when it comes in. So text is pretty much out. You've got applications like Google Authenticator or Microsoft Authenticator or Authy. There's lots of those available. The work we're doing today technically could be used with any of those, but we're going to use Google Authenticator. And then the other mechanisms involve putting applications onto your device, which get a message pushed to them by the other end. We're not going to cover that, and that's quite expensive and a little bit more work. Okay, so if anybody hasn't got Google Authenticator on your phone, you might want to install it now as I'm burbling away, and then in a moment you can actually come along with me and do what we're doing and see it working on your own device. So basically, for this method of 2FA, the user has to have Google Authenticator installed. Sometimes there's reticence about that because people associate Google with phoning home, and actually Google Authenticator has had a bad reputation in the past because a lot of the implementations did involve phoning home to Google. The implementation we're doing today does not phone home to Google, and Google Authenticator does not phone home to Google. Once you've installed it, you can in fact turn off Wi-Fi and data, and it will function exactly the same fashion. It's not phoning home. What it does do is it reads a QR code provided to it, which seeds an algorithm, and Google Authenticator sits there updating the value from the algorithm so that when the user goes into Google Authenticator, they can read a code off their account and enter it into your dialog. And it's a time-sensitive code, which means it updates every few seconds. I'm just going to actually show you this if I can. And it's opening in the wrong page. Let me just bring this down so you can see it. All right. Okay, so this is an online authenticator example. We're going to look at this one, and then we're going to do it ourselves using VFP. So the first step is to pair your application with the user's device. That's also called registration. It doesn't really matter. So if I click pair, hopefully you can all see a QR code. If you've got Google Authenticator installed, the instructions say to press the plus icon on the top right. I think it's bottom right these days. And then there should be a scan barcode or scan QR code option. And if you do that, then you should end up with a new account in Google Authenticator, which is using this QR code as your registration. So when you're installing Google Authenticator, it's going to ask for access to your camera, and that's not so it can take snapshots of you and sneak them back home. It's because it needs to use the camera to read the QR code, and it may also ask you for access to your file system, and that's so that it can save the key or the seed for your authentication. So I've just got I've just got it up. I go scan QR code, and I've now got the Google Authenticator installed on the machine. So those who've done it will be able to see that there's a 30-second update occurring, and every time you can actually see there's a kind of a countdown. I'll show this to everybody in a moment with the VFP version, and the code updates. So basically, if I close that, if I now go validate, now anybody who's installed it will know, as I do, that the code is 833043. So I enter that, and of course it's not in the right place and it's just changed. So I'll try again, 801865, and I'm told that my access is granted because I got the code right. And just to confirm, if I get the code wrong, I'm denied access. So that's basically how Google Authenticator works. You register the account or pair the account onto your Google Authenticator, and then when you go to log in, you simply read the code of Google Authenticator. It's calculating the code locally. There's no phoning home, and your application calculates the code, and as long as they match, you're in. There is one problem with this. If we look at the page source, this is a sample page or test page, but if you look here, it's using the Google Charts API to generate that QR code. And if you go online and search, you will find that almost all of the published implementations are using the Google Charts API. And in fact, there are even net samples which appear to be doing it locally, but when you dig into them, they are in fact utilizing the Google Charts API. So that's obviously phoning home, but more importantly, Google has said that it's deprecated as of 2012. And while it's still there, you wouldn't want to build anything around it. And last time I looked, this application is also using the Google validation routine. So it's phoning home again to validate the code. The problem with that is you've got to send your secret code every time you validate the user's entry, which means you're telling Google what it is again, and it's going across the internet. So this is not ideal, and we would like to do better than this. Okay, so let's have a look at doing this in VFP. I'm just going to pull this down here now, and I'm sorry this is no longer, I'm just pulling my presentation down, or at least trying to, so that you can see it. It appears to be stuck. Okay. I'm sorry about this. My system appears to be playing up, and I'm not able to show my slides properly. I may have to open and close them again. Let me just quickly come down here and see whether it will now. Okay, so what's happened is that my presentation is playing up. I'm not able to show you my next slide. So while I think about that, what I'm going to do is I'm going to go into VFP, which hopefully you can see, and I'm going to have a look at some code that I've prepared to show you how we can do these things in VFP. Okay, so the slide that I was going to show you basically says that I'm not really the author of all of this. I'm standing on the shoulders of giants, and I have pulled together a whole lot of bits of functionality performed by various VFPers, which come together to make really quite a nice facility for our use. So the first thing we're going to use is the XFRX Fox barcode QR project. And basically, that's in FXRX, and it is a pure VFP implementation of QR codes with no phoning home. We're using Craig Boyd's VFP encryption for MDAC, which is utilized in the algorithm and also for hashing. And what I've done is I have subclassed the Fox barcode QR code into my own QR2FA class, which has a number of things. So the first thing is Google Authenticator uses a secret code to seed your account or the user's account. And in that way, it's a bit like VFP's RAND function. You know how with RAND, if you were to seed it with, say, the number 100, then every time you call RAND from that point, you're going to get the same pseudo-random number. And that means you can force the same numbers to be produced every time just by putting 100 in at the beginning of your algorithm. Similarly, when you put that secret code into Google Authenticator, it relies on the pseudo-random number generator to know at 30-second intervals what the code will be. And Google Authenticator calculates it, and we calculate it at our end. You need the secret to be unique per user, because otherwise any user can utilize the QR code to unlock another account, which we don't want. And you need a little bit of obscurity so that somebody can't figure out your algorithm and then guess what the QR code's going to be based on that. So here's an example which is using the user's user. Yeah.
John, pardon the interruption. We've been asked if you can increase the font.
Sure. How's that?
I can't say how it is in the live room, but larger is better. So.
Okay, it's all VFP code, so I'm happy to make it. That's pretty big now. Hopefully, people can see that. Okay, so as I said, that's just an example of a secret code which is deliberately injecting a bit of obscurity. And what happens is that when the class that I've created is initialized, you can either pass a new secret code to it, or it will use this calculated one. And from there, you can generate a QR code just by calling this function. And then you can also validate a supplied code by calling validate 2FA code, which tells you whether or not that code is correct. So this single class then becomes your mechanism to implement 2FA in your application. Now, if I run it, theoretically, you should get a QR code come up. And if anyone's got Google Authenticator, if you now scan that, so press the plus button at the bottom right, scan a QR code, you should see an SW Fox 2023 account now appearing in your Google Authenticator, and you should see a code that is counting down. For those who haven't installed Google Authenticator, I got you. This is what they're seeing. Now, this was recorded earlier today, so the numbers here won't perfectly match what they're seeing. But what you can see is that there's a kind of a countdown timer here that you can hopefully see. And when that hits the 0 point, this code updates. So the user basically fires up Google Authenticator, reads the code of SW Fox, enters it into your 2FA dialog, and if they're correct, on they go. And in about 15 seconds now, it's going to update to the new one. Now, this has all been calculated locally. It is not phoning home to calculate this. And we didn't phone home to calculate that, to produce that QR code. So we are meeting our goal of not phoning home. All right. My difficulty now is that with this big resolution, I cannot close this form. Let me just see if I can use Control F4 in it. Here we go. Okay. So that shows you how we create the QR code, which makes it very easy for the users to register the account. I'll leave it to you to decide how you would distribute that to your customer and users, but it is generating an image. And for that example you just saw, all I've done is create a form and put the picture equals that image, and it displays it for you, but you could do whatever you like with it. And the Fox barcode QR has numerous options as to how you can produce that code. Okay, so now the users come to log in, and the question becomes, how are we going to validate the code? What I'm going to do is I'm just going to lift that from there because it's easier than typing it. And I can now go print. And I'm going to go to my Google Authenticator. I'm going to read off the code for the Southwest Fox 397341. And I can get it true, which is just printing on the backdrop of the VFP screen there. If I get it wrong, it'll be a false. And everybody who's got Google Authenticator can see that the code has now rolled over. And yet, if I perform the previous code validation, I still get it true. And the reason for that is that you might have a disabled user, or you might have a user who begins typing the code in at 27 seconds. And they won't appreciate that by the time they finish entering the code, it's now rolled over to a new one. Or the Google Authenticator could be installed on a tablet with no internet access for security, because people are a bit worried about phoning home. And in that situation, it's not uncommon for the time on the device to be slightly out of sync with the proper time. And you can run into difficulties there where it can become impossible for people to log in. So what I've done and you can do this or not do this as you see fit, is these two functions. There's current 2FA code, which calculates the 2FA code at the current UTC time. So if you're interested, you can have a look at the actual algorithm here. It basically calculates an offset between the UTC time and the beginning of 1970 and utilizes that as part of the calculation. So that's something I need to raise with you. In the supplied class, it's using sys 9028, which is a VFP-A function to calculate UTC time. If you're not using VFP-A, no problem. Rick Strahl has very helpfully published a function you could use to calculate the UTC time, and I've put the URL there so you can just go and lift that. Or if you're using VFP2C32, it has got an inbuilt function which will give you the UTC time. Either of those is fine. If you're using www.api.prg as part of Westwind Web Connect, you've already got the UTC function and you can just address it. I've just used that for my own convenience. And that is the only dependency that you would need to possibly change to make this run. Otherwise, you can just put this onto your PC. Excuse me. If you've got the all of the files I've provided in the zip file for this system, you should be able to just run this and it'll produce that QR code. And you'll be able to validate codes using validate 2FA code. So that's the current code. And what validate 2FA code does is it acknowledges that possibly you need to do an offset of a plus or minus one or more period. And the implementation I've put here, if you don't pass parameters, it goes -2 30 seconds. So that's -1 minute. And then +2, which is +1 minute. And it will actually validate the user as long as they get one of those correct. So that means even if there's a slight drift in the time, it doesn't matter. Your system is still going to work. And you can customize that as you see fit. I would recommend against utilizing just the pure current 2FA code, because people are often going to still be typing when it changes, which is annoying when they get told it's wrong. And also, you might have a disabled user who simply can't get their code in within 30 seconds. And so therefore you need to at least be looking at one before to make sure that you're not being unreasonable. Okay, so I don't think I need to belabor how easily people could incorporate this into their current systems on top of their existing login mechanisms. Now, if you'll just bear with me, I'm going to try and get this to come back. And I did it. There we go. So we'll just whip through these because I've already covered them all. This is just a thank you slide. So that Fox barcode QR was produced by a friend from Spain and another from Argentina. I believe Guillermo is no longer with us. Olaf came up with the original validation VFP algorithm. It incorporates Martina's encode 32 libraries, which are bug-free and work. When you look at them, you might think that you'd do some parts differently using private variables that remain in scope, but they work, and I haven't messed with them. And the UTC time calculation is either done by Chen, by Rick Strahl, or as part of that DLL I showed you. MDAC and hash by Craig Boyd. All I've done is bring it together in a few lines of code, and any of us can implement that into our systems with relative ease. There's no phoning home. There's no excuse for phoning home. We don't. Right. Login authentication. The first option we talked about was auto login, basically using the Windows username. I don't need to tell this audience how easily you can extract the Windows username in VFP. You can either use the environment variable or you can use the sys0 function. And there's your username. And as long as that username has got privileges in your app, they're in. One thing to think about, are they logged into the correct AD? It becomes possible for a hacker to either create an account name on their local PC and log in as that, or log into the wrong AD and try and spoof privileges across to your one. The obvious response to that is, well, you'd expect the AD to be set up properly so that if the user's not logged into the correct AD, they haven't got access to the resources or database. And you might well expect that. But I had a situation with a very large customer where after hours and in response to a crisis, somebody quietly granted the whole AD access to the C drive on a server, which solved the access problem which had been experienced. And that wasn't noticed for quite some time. So you might expect that the customer's got their AD set up properly, but can you guarantee it? And who will they blame if a hacker is able to do stuff they shouldn't by spoofing a user account in your application? So look, it's not hard to check the user domain environment variable, except that, of course, that variable gives you a clue that that can be messed with. You need to decide how far you want to go with this. If you're being paranoid, and once again, credit to other people, Anatoly who started it, and then with apologies to any Norwegian speakers, Tore and Doug and Bernard are all responsible for this Win32 API. And if we just click that link, hopefully it will give us a sample which allows us to pull the domain name for the user. So if you want, you can implement this code to look at the domain name. If you don't like that one, there's another example there. I'm not going to belabor this. My advice to you is to go online and do an internet search on the APIs that are being called, because sometimes it gets locked out or blocked by the customer. And if you've built this into your application, suddenly it stops working because a new security protocol has gone in. No one's going to thank you. So my approach is utilize the sys0 function, utilize the environment variable, and just tell them that's as far as you've gone. The rest of it, the AD security part, is entirely on them. Okay. Next, Active Directory authentication. So basically, this brings up the user login dialog, just like your classical version, but instead of authenticating against your user table, it's going to authenticate against the customer's AD, Active Directory server. And that uses a Windows API. We're going to look at this shortly. All I would say to you is you need to be careful. Just because they're all called AD does not mean they're the same. So the username that's required for this API has got multiple options. The UPN being the newer format, the SAM being the older format, and the terrific error handling which is offered by this API, which means no matter what the error is, even if you've spelled the AD wrong or have used a fake AD, you're going to get an error 1326 username or password is incorrect, which is terrifically helpful. And let's have a look at it. So I've produced some code here, which is included in the zip file that's come with it. This is very simple code. You can find this code in Westwind Web Connect and elsewhere. Quite a few people have published it. You declare one API function, And then you call the API function with the username and AD parameter and the password. And basically, you get a success or failure message back. Okay, now, username format. It varies. Some AD requires the UPN format, which I mentioned is the newer one, which is this format. Oh, I'll just make that bigger so you can make sure you can see it. How's that? Some requires the UPN format, which is username at domain. Now, technically, this could actually be the user's email address, but it doesn't necessarily have to be. And the other one is just be aware that UPNs are optional in AD. They may not be present, or that you may actually have to use the SAM or down level format, which is domain /username. And a little bit of history, that SAM was introduced with Windows NT. Back in those days, it was a maximum 20 characters for this SAM user identifier, which needed to be unique on your domain. And SAM was introduced, I beg your pardon, UPN was introduced with Windows 2000, and that one needs to be unique on your forest. And despite the fact that 2000 is quite a few years ago now, I think anybody who's logged into an AD using Windows 10 or even Windows 11 is likely to recognize this ancient format. It's still hanging around. For your users, they're probably accustomed to logging into your application just using a username, not domain /user or anything else. So you would need to assemble either the UPN or the SAM username for utilization in this logon user. And here's where it starts to go haywire. If you specify the UPN format to this API, then this parameter has to be a null. Otherwise, guess what? Error 1326, the username or password is wrong. So you've got to pass a null for that. If you're utilizing just the username or the down level logon name, you may or may not need to specify this password, almost certainly do. So there's multiple variants for you to experiment with. And after you've experimented with them all, if you still can't get in, it means that it's locked down, because logon user actually is a known vector for hackers to impersonate users to cause problems. So a bit of work required, may well be locked down. And although this is available all over the place, I would recommend that you don't try and use this mechanism, because even if it does work today, it might not tomorrow. And also, your users are almost certainly accustomed to entering just their username and are not going to be excited if they've now got to enter their whole email address or domain /username. You're going to need to assemble it anyway. Okay, so didn't I do well? I've somehow managed to lose the okay, so sorry about this. I'm just having, for some reason, the okay, I'm just going to drag this down here because my presentation is playing up a little bit, and I'm not able to easily show you the screen I'd like to show you. Hopefully it's now back. Okay, so this is what I recommend you use if you're trying to do AD authentication, LDAP, lightweight directory access protocol, used all over the place, used widely in Linux. It's used for AD as well. I think it's been present in AD since around 2000. Customer just needs to turn it on. It's got enormous functionality. It's got enormous abilities to enable and disable features, and it actually produces more than one error message. So quite useful if you're trying to figure out what parameters need to be passed. And there's a whole new set of jargon required, but as I'll show you in a moment, to authenticate, all we need to do is bind. So in LDAP, you connect to the LDAP server, and then binding means you provide a username and password, and LDAP tells you whether or not it recognizes you. And from there, you can perform searches and change privileges and things. But basically, you can't block bind because otherwise LDAP would become unusable. And therefore, bind is a very reliable way of determining whether users' credentials are correct. So that's great news. If they've got LDAP, you can almost certainly use it. There are a few gotchas, and we're running out of time, but I'm going to go through them because it does matter. That bit there in bold is highly recommended. In your customer, LDP.exe is in fact a Microsoft application. It came with Windows Server 2008. It doesn't anymore, but you can download it and run it. And it runs on Windows 10, Windows 11. It's just coming off the screen here. Let me just bring it back in so that you can see it. Okay. I'm sorry, the font's a little bit small. I don't know whether I can increase it. I can try, hang on. No. Okay. So with LDAP, LDP is basically a graphical user interface for LDAP. And if I now open the VFP code that belongs to this, you declare a function to initialize the LDAP function. You declare the bind function. You can optionally set options in the LDAP, and then when you finish, you unbind it. And there's a number of port options. And I've got some sample credentials here, which we can use to test this. So if I go into here and go connect and connect, so there's the name of the server. That's the next point. In the AD integration, that AD parameter can either be a domain or a server. You need to find out. This is a server. So you connect to a server with a designated port, and okay, so we've established a connection. And that tells us that that's good news. We can then do a bind. So this is the standard Linux LDAP. So UID is user ID, DC's domain component. And I happen to know what the password is, and I was able to bind as Einstein using the password. That means the Einstein user ID and my password were correct, and I can now unbind. And the good thing is, this actually tells you what the command is so that you can make sure you've got it right. As you'll see, I haven't used these commands. I've used my own, and I would recommend you go for mine because LDAP_open is being deprecated gradually, and the recommended way of doing it now is LDAP_init, which is what I'm using. And also, they've used LDAP simple bind, and I've used the standard bind function with the simple opt version. You need to have a look at some of the comments in this code. But what we'll do is, you've just seen me connect and authenticate using LDP. If I run this code, so if we run through what it did, it initialized to the server, which is specified as that same one we used, and it then bound the server. It did an LDP set option. So when you're looking at LDP, one of the good things is you can confirm what version of LDAP is being used by the user, and it's worth putting that in here. It's almost always going to be version 3, but it doesn't hurt to make sure. We do an LDAP bind, and we then do an LDAP unbind. And if there's an error message, it is just a number, but I've included some reasonably useful functions there. That these are the sorts of error messages you might see from just binding. There's a forest of other error messages to do with searching and other things. But these are the ones that are just for binding. So using LDP, you can confirm what needs to be passed. If you're connecting to AD, what I find is that quite often the bind, you can use that SAM format. So it would be something like that, which is a lot simpler in AD integration. And you can experiment with that and just try the different formats that we've talked about. One of them will work. It's probably going to be that one you've just used against AD. And if you're lucky, your customer will have somebody who's done it before for another vendor, and it'll be easy enough for you to figure out what has to be applied. I can't tell you exactly what your customer's AD will use, and that's why I recommend using this LDP. Now, once you're connected and bound, you can do other stuff like searching. So if we go to browse search, if I do a search on just on Einstein, you can see I get back quite a lot of stuff here. I get his email address, and I get his telephone number, user ID, and a hashed version of the user password. So that function is likely to be locked out. So you might be able to use searches to see what groups the user belongs to, but in my experience, that's usually locked out. They don't want people doing searches on what groups users belong to. So theoretically, you can use LDP easily enough to figure out what groups or organizational units a customer belongs to, and you could use that for privileges, but you need to experiment with the customer, and you may well find that's more difficult than it looks. So that's LDAP. That's how you bind. That's how you can authenticate using LDAP. I would recommend you use this one. Very reliable. There will be a way to do it, and it's usually that SAM format and the password. I didn't really look at it much. I think I need to. I'll spend a couple of seconds on it. This matters. Now, the port 389 by default is not encrypted, and port 636 by default is encrypted. You really want to use port 636 because otherwise you're passing credentials in the clear across the customer's network, possibly across the internet. That example, that sample that we looked at before doesn't have port 636, which is a problem for it, but you definitely want to use that if you can. And in fact, I've incorporated that in my code. It defaults to the secure port unless you specify one. Okay. Let's see if we can get back to our screenshot. Slideshow, start from current slide. Okay, so to authenticate, all we need to do is bind. You can't block bind because otherwise nobody can get in. Very reliable, good way of authenticating. the distinguished names do differ, and watch out, some bigger customers have aggregators, and don't forget it's a server that you're authenticating against, not a domain, and utilize ldp.exe. All right, fun with OAuth 2. OAuth 2 is probably the best known so-called modern authentication, and it boasts that it's the industry standard protocol. So it came about by people needing to have access to Twitter resources. In the client-server model, you would need to provide a third party with your login credentials so they can access your resources. You don't want to do that. There was no mechanism to allow third parties to access resources without those credentials, and so OAuth was invented, the predecessor of OAuth 2. So its principal purpose might be to allow, for example, a print shop to have access to your images without them needing to know your login details. Now, you might say, well, that's not really something of much use to VFP developers with their database applications, except that OAuth 2 can also be used to provide single sign-on. So if you can imagine your customers put everything up in Azure, the expectation is the user logs in once into Azure, and then from then on, there's OAuth 2 authenticated tokens being passed around to give them access to everything they need without having to log in again. So you can't ignore this. However, it's not actually an authentication protocol, and in fact, the inability for the third party to see your login credentials is one of its most important benefits. So if you want to use it for the purpose for which we need it, you're going to need a second token or other mechanism to pass around what the user's ID name is. And what you're going to find is there's complications and unexpected jargon, and OAuth 2 does advertise availability for native apps, but the standards are fluid. You're going to be doing a lot of roll your own. It's significant that OAuth 2 is not backward compatible with OAuth. So in the current state, if you roll your own stuff, don't be surprised if when OAuth 2.1 comes out, there's something better and you've wasted your effort. And so, especially for native development, an awful lot of the discussion of OAuth boils down to it's coming. Okay. There are Chilcat libraries that encapsulate a lot of the functionality, but OAuth 2 is just an HTTPS protocol. You are sending and consuming HTTPS messages. And in the old days, you had more control. You could, for example, bring up a web browser control and do all the OAuth stuff inside there. But the new standards say it's got to be done in the standard browser. And what I've done is it's probably easiest to give a demonstration of this. So this gives you a feel for how all the flow works. So if you wanted to offer your customers OAuth 2, you become a client. You may not understand that, but that's what they call you. And you need to register your application with the OAuth provider. So here we are registering ourselves as a client. So these two values here are for your application. And these are what you use in OAuth to say, is my user logged in? And to get authenticated tokens to allow them to utilize resources. And this is just a sample user account that we're going to use. So if I just put that out of the way, back to flows. So we've now registered our application with the OAuth provider. The user logs in and we now need an authorization code. So basically, we send this to the OAuth provider in this example. Now, this is not standard. depending on your OAuth provider, you may well have to include meta tags, so it's in the header, or it could just be HTTPS parameters, as you're seeing here. So be ready for a whole lot of roll your own variability. But I think any of us can look at that and see it's not difficult for us to manage this. There's a redirect so that after the user successfully logs in, this is where it's going to come back. It's that one. Straight away, you can see an issue if you're running a native Windows app. Native Windows apps don't have redirects, but we'll come back to that. So we go to authorize, and it wants us to log in using, where's that gone? There, using that. Blue-eyed thrush and dull mole 65. Awesome. Login. Now, in this case, it's being used, as we talked about, for access to resources. So we approve it. Okay. And it comes back to the client, and there's the state. So when we initiated that first hit, we included a random state of our own. And because it involves a redirect, you need to make sure that the state matches when the redirect comes back, to make sure you're not getting some other person trying to spoof you with their own one to try and trick you. So that state has to manage the state that was in the submission that you made. And we've now got an authorization code, and we can use this authorization code to generate an authentication token by producing this HTTPS message. Once again, there's a redirect URL. Here we go. And this is what you get back. You've now got an access token. And this access token, depending how the OAuth integrates with other things, can be used, could be used, for example, to access SQL Server, to access resources on Azure, or lots of different things. You need to look at this refresh token. Yes, they do expire, sometimes quite quickly. And when they expire, you need to be able to refresh them. So you're going to need code for that as well. So I think, although I'm not providing you with the code for this one, that's because there's so many different variants. And the best advice I can give you is wait for OAuth 2.1. There's a lot of standardization coming. There's libraries coming for native Windows applications versus devices versus browsers. And anything you do now, you can expect to have to write different code for every OAuth provider. So Google is very different from GitHub, which is very different from Azure. So you're going to have to write lots of different variants. And I think if you tell your customers that once we're standardized on OAuth 2.1, it will be offered, I think they're probably going to be happy with that. Now, if you're doing native Windows applications, the redirect is a problem. But as I said, we're building on the shoulders of giants. We can actually handle that. So the redirect, if you make the redirect localhost and a port, then you can just listen on that port and you can catch the redirection when it occurs. So thanks to Marco Plaza for this one. That's not actually what this is doing, but it does demonstrate kind of how it's working. I need to do a set path to make this work. Give me a moment. I would have thought that would work. Hang on. Let's just brute force that in. Try again. Still doesn't like it. Okay, well, I'm sorry, I'm not able to. Oh, it did partly run there. No, it's not doing it. Okay, so what this code that I'm failing to show you there does is it's got a port listener built into it. So that tiny piece of code there is listening on local port 224. So you could utilize this, and you've got this next bit there. It's got an event handler in it. So you can actually have an event handler bound to the listener. So what you do is in your native application, when you're trying to use OAuth 2, you produce those HTTPS. You send them to the OAuth provider in the browser. It's got to be in the native browser, so you've got to bring it up in the browser. And then you can make the redirect localhost : and this port, and you can just sit there and listen for it. And when the redirect occurs, you can handle it. So that just shows you how you can use OAuth 2 for a native Windows application. I think I'm perilously out of time, but that probably concludes as much as I can squeeze into a 1-hour presentation. So if we just go back to here.
John, you actually have another 15 minutes if you have more you want to show.
I think I've probably got to the limit of what I can squeeze in.
That's fine. We also have a few questions if you want to take them now.
Okay, good. I'm happy to answer questions. So hopefully what I've shown is you've got multiple options, and they're actually all very easy to implement. It's not hard to intercept your existing login dialog to authenticate against either AD or LDAP. It's not hard to add a 2FA requirement, no matter what form of authentication you're using. We saw that we can do our own QR codes very easily, and we can actually calculate the Google Authenticator codes without phoning home. It's all pure VFP, and it's all done using the Windows API, not scripting host or other potentially dangerous dependencies. And that's it.
Okay, so there were a couple of questions from attendees, and I imagine you'll get some more when you get into your session room. But somebody asked, do users complain about the two-factor authentication?
Usually, by the time you're asked to do it, they've already got it for other systems, and they kind of roll their eyes. So I think for you, it becomes a useful optional feature. When asked, you can say, why, yes, for only an additional $1,000, we can enable the 2FA module, and you can then turn that on, and then it's over to them. So this code that we're using is actually an industry standard. It's the same one is available in Authy and in Microsoft Authenticator, as well as Google Authenticator. So you've got lots of options there. It does have some limitations. It is only 6 characters, which theoretically you might say is not enough, but it's also free. And I think most customers are impressed by free.
Okay, and the other question, can you speak to using LDAP in a web application environment?
Sure, it works fine. We use it. So basically on the server, you intercept, when you've got your login dialog, that comes back to the server with presumably with parameters, however you've done it. And you then do the LDAP bind. If you're doing it on a server, you probably don't want to keep declaring the LDAP functions. I think Rick Strahl did some testing and confirmed that there is a definite performance hit from repeatedly declaring functions. So you'd want to do those once, and you just do exactly the same thing. You connect to LDAP, you bind, and you unbind. And it's very quick. And we have that functioning at the moment. The only potential difficulty in the web is you need to show the customer your QR code, and you'd need to think about that. That probably doesn't exist at the moment. But that's between you and your customer as to how you want to do it. LDAP's great because when you think about it, if they disable bind, you actually can't use it. Nobody can get in. So you're going to be able to bind to it. It's quite good.
Okay, that's all the questions we have right now.
Okay.
So,
well, shall I wander over to that post-session thing and see if anybody else wants to ask me anything?
If you're done, we will stop the stream and you can go there.
Okay. I could spend a few minutes embarrassing myself trying to get Marco Plaza's excellent port listening code going. But I don't think it's important enough to be worth making everyone watch me do that. I think people are able to get that going themselves, and they can see what the useful functionality is. So that's included in that zip file that I've provided if anybody wants to have a crack at it. Okay, I'm happy to wander across if it meets people's needs.